Ever wondered how a multilayer perceptron works in a neural network? Let's dive into it. The multilayer perceptron, or MLP for short, is a type of feed-forward artificial neural network. It's a fascinating structure composed of an input layer, one or more hidden layers, and an output layer. Now, what's intriguing is that each of these layers is fully connected to the next one. This interconnected architecture allows for complex data processing and pattern recognition. Imagine a web. Each point in the web is a neuron, and all these points are connected to create a network. That's essentially what MLP is, a web of interconnected neurons working together to process information. But what's the purpose of all this? Well, MLPs are the workhorses behind many supervised learning tasks. Tasks like classification and regression, they often owe their success to the multi-layered, interconnected structure of MLPs. The MLP, with its layers and connections, forms the backbone of many supervised learning tasks, including classification and regression. So what exactly goes into the structure of an MLP? Let's delve into the details. A multilayer perceptron, or MLP, is basically a sandwich of layers. It starts with an input layer, followed by one or more hidden layers, and finally an output layer. Think of it as an information highway where each layer is a checkpoint. The input layer is like the entrance of the highway, receiving the raw data. It's in the hidden layers where the magic happens. Here the data gets processed, transformed, and passed along. Each hidden layer is a collection of neurons or nodes, where each neuron is connected to every neuron in the next layer. Finally, the output layer is the exit point of our information highway. It produces the final result, whether it's a class label in a classification problem or a value in a regression task. Each layer of an MLP plays a crucial role in processing the data and producing the desired output. How does an MLP fit into the bigger picture of neural networks, you may ask? Well, MLPs play an instrumental role in the grand scheme of neural networks. They specialize in supervised learning tasks, which include classification and regression. Simply put, MLPs are the go-to guys when we need to predict a specific outcome from a given set of inputs. What sets MLPs apart is their feed-forward structure. This means that they pass information in one direction only, from input to output. There's no back and forth or roundabout routes here. This one-way flow of information makes it easier to track and understand the process of data transformation as it moves through the layers of the network. It's like a well-oiled assembly line where each layer adds a new dimension to the data, refining it until we get the output we desire. In essence, MLPs are the workhorses of neural networks, powering many supervised learning tasks with their feed-forward structure. Ready to see an MLP in action? And let's dive into a practical example using Python and the sklearn library. Here, we first import MLPC classifier from sklearn's neural network module. This is our main actor, the MLP. Next, we define the MLP model. The hidden underscore layer underscore sizes parameter is set to a tuple of two elements, 150. This means our MLP has two hidden layers with 150 neurons respectively. Max underscore iter is also defined as 500, which is the maximum number of iterations for training the MLP. Once our MLP is defined, we fit the model to our training data, x underscore train and y underscore train. This is where the magic happens. The MLP learns from the data. Finally, we use the trained MLP to make predictions on our test data, x underscore test. And there you have it, an MLP hard at work on a supervised learning task. So we've demystified the multilayer perceptron. It's an integral part of feed-forward artificial neural networks, with its distinct structure of an input layer, one or more hidden layers, and an output layer. We've seen its role in supervised learning tasks such as classification and regression. We even put it into action with a practical Python example using the sklearn library. Next time you hear about multilayer perceptrons, you'll know exactly what's going on under the hood. Keep exploring and happy learning.